Today we're very lucky to have Ameet Talwalkar. Welcome to the podcast.
Hey, thanks for having me.
Of course, do you want to talk a little bit about how you first got interested in computer science?
Yeah, so I guess I'm dating myself a little bit, but I came into college as I would say pre-med.
Mm-hmm.
I took my first computer science class my sophomore year of college.
Mm-hmm.
I really liked it, but it was more just I was pre-med and I was an econ major. I didn't find econ in particular to be all that interesting.
Mm-hmm.
And no real experience coding or doing anything up until sophomore year of college.
Mm-hmm.
And it was fun. I always liked math. It felt
Mm-hmm.
like math, but maybe a little bit more practical in some ways.
Mm-hmm.
So I was an undergrad CS major. Didn't necessarily know what, if anything, I do with it afterwards. After college, I worked for a consulting company, management consulting. I
Mm-hmm.
actually jumped. I did that for a few months. I worked for a software startup.
Mm-hmm.
I worked in a neuroscience lab. Kind of didn't know what I wanted to do,
Mm-hmm.
and applied to grad school after 3.5 years of
Mm-hmm.
working full time at various jobs.
Mm-hmm.
Sort of barely got into grad school too, right? I had good grades as an undergrad, but very little research experience, and sort of applied to a bunch of schools. I think I got into maybe only NYU,
Mm-hmm.
but was very fortunate to get to go there, and the rest is history.
Gotcha. So I guess like what made you want to go to grad school in the first place? You talked about how you had 3.5 years of work experience. Like why the change?
Yeah, I mean, I think it was one of these things where partly I didn't, I would argue that part of the reason you want uh, students to have research experience before they start their PhD is because that they know what they're getting themselves into, for better
Yeah.
or worse. And truthfully, I just don't really think I knew what I was getting myself into. I knew I liked undergrad computer science.
Mm-hmm.
Undergrad courses are very
Mm-hmm.
different than doing research.
Yeah.
So from that point of view, like my reasoning at the time, I think was probably not, not the best reasoning. But yeah, it was sort of I can't say I had a crystal clear reasoning for it, other than that I wanted to learn more about computer science more
Mm-hmm.
broadly.
Mm-hmm.
And I would say maybe I had this general thought that I liked intelligence, I liked the
Yeah.
brain. I worked in a neuroscience lab
Yeah.
previously before with the idea of, taking the black box and trying to explore it and poke around and try to understand what was going on.
Mm-hmm.
That seemed interesting and sort of very noble at a high level, but
Mm-hmm.
it wasn't kind of scratching my itch intellectually of thinking about things algorithmically and mathematically.
Mm-hmm.
Whereas, back then with ML, it was kind of bottom up. You were starting from first principles, trying to create, machine intelligence or machine learning, whatever you wanted to call
Mm-hmm.
it. So I like those ideas in the abstract, but the truth is I didn't really know what I was getting myself into.
Gotcha. So maybe walk us through a little bit about your time at NYU and then, the postdoc and what motivated that.
Yeah, so I started grad school in 2006. It was, I did not know what the phrase machine learning was when I started. I was a very, I had some life experience because I'd been working for 4 years living in New York,
Yeah.
but I'm very green in terms of research or what academics was or what a PhD even was.
Yeah.
Um, and no, but it was fun, right? I was motivated I jumped around a bunch the 4 years before, so I was motivated to succeed at kind of whatever I was going to do
Mm-hmm.
because I didn't want to keep jumping around. But yeah, machine learning was very different back then, right? Neural networks were not in vogue. It was all convex optimization. You had to have a unique solution. A lot of machine learning was very, very mathy. My first introduction to machine learning actually was basically computational learning theory, which was kind of and I would argue still is a big area within the area of machine
Mm-hmm.
learning. So that was one aspect of it. The field was completely different. But the other aspect of it was that my advisor was consulting with Google Research in New York.
Mm-hmm.
He still is working there. But so I spent, I would say, a good portion of my time in my PhD summers, but also otherwise,
Mm-hmm.
either explicitly interning at Google Research or, informally collaborating with folks there. And that was nice for me because I think my interests, even back then, were always at the intersection of, I wanted to come up with principled approaches and new algorithms and understand things conceptually. But I wanted to work on problems that were real and that,
Mm-hmm.
where I could have this translational impact.
Mm-hmm.
And again, it was a different time in the late 2000s for machine learning, but Google was trying to do real things and cared about things actually working. And so being around at that time, massive compute, massive amounts of data, it was sort of, Google was certainly ahead of its time, and it kind of got me excited about it, doing things at large scale and trying to do things that actually could have translational impact.
Mm. Gotcha. And you ended up getting your postdoc at Berkeley afterwards. So maybe like what motivated that?
Yeah, so I mean, again, it was one of these things where I was at a crossroads when I finished grad school.
Mm-hmm.
It's funny, I advise all my students now in a certain
Mm-hmm.
way to how to do things the right way. It's not clear, but I did things the right way when I was graduating. I thought about starting a company.
Yeah.
I had an offer at Google Research,
Mm-hmm.
and I applied to, I think, exactly one postdoc, which was at Berkeley in Mike Jordan's lab at the time.
Yeah.
And at the time, Mike Jordan was, in my mind, the preeminent researcher in
Yeah.
machine learning. He is an absolute legend. Also, very, very good human being, a great mentor. Former students and postdocs, I think, pretty much unilaterally rave about him just as a mentor and good person.
Mm-hmm.
And so having the opportunity to go there was sort of, as an academic, as a researcher in machine learning, it was sort of an opportunity you kind of couldn't pass up.
Yeah.
Very fortunate that I took it, but it was one of these things where, it was not obvious that I would stay in academia. And had I not gotten that postdoc, my two fallback options were either start a company or work at Google Research.
Mm-hmm.
So
Gotcha. And after your postdoc, you ended up going to UCLA to become a professor. So, I mean, you talked briefly about how you had this idea of starting a startup, and I mean, we'll get later into determined AI. But why become a professor instead of go straight into startups?
yeah, well, I guess there was a gap year in between there. So
Yeah.
I did a very long postdoc. I did a
Yeah.
short PhD,
Yeah.
a long postdoc at Berkeley.
Yeah.
But then I took a year off actually before even my PhD. I worked at Databricks
Yeah.
when it was a small, I don't know, 10 or so person company.
Mm-hmm.
So that was kind of, I had an experience as a startup before I started grad school,
Mm-hmm.
and then had this experience at Databricks. It was clear that they were going to be a rocket ship, but
Mm-hmm.
when I was there, it was still very small.
Mm-hmm.
So that was also really fun, and it was nice to kind of just see what I was certainly not a founder. I was doing kind of my small thing on the side there, helping create some educational software for them, but just being around all of them and seeing what was happening was kind of really fun.
Mm-hmm.
No, but I mean, I think I think the field of machine learning was different back then. I mean, I still think that there's a lot of merit of being a professor today,
Mm-hmm.
but back then I think that there were, I guess it was just what I was passionate about. There were a lot of open problems to be studying, and it was something that I had had my kind of I had been focused on this idea of being a professor for a while, and I'm trying to think what was my partly I just viscerally wanted to be a professor, right? I've been
Yeah.
shooting for it. The opportunity presented itself. It seemed like something I didn't want to pass up,
Mm-hmm.
but I think I kind of I wanted to see what it was going to be like.
Mm-hmm.
I also wanted the ability. I kind of knew from the start that I would really like mentoring PhD students.
Mm-hmm.
It's one thing to do it informally as a postdoc. It's
Yeah.
something else to do it when you're actually a professor and have students who are your advisees.
Mm-hmm.
So it was something I'd hoped that I would be able to do.
Mm-hmm.
And I guess maybe a related point is I think this is still largely true in academia, but it certainly was true back then. It's much easier to leave academia than it is to come back to it.
Mm-hmm.
So if you have the opportunity to be a professor, if you don't take it and leave to do anything else, no matter how exciting, how high impact it might be,
Yeah.
for whatever reason, it's very hard to get back into academia.
Mm-hmm.
Not saying that's a good quality of academia, but it is just de facto
Mm-hmm.
how it is. And so given that I, been gearing up to try to get a position in academia and was fortunate and lucky enough to get one, I wanted to see what it was going to be like.
Mm-hmm. Gotcha. And getting into your time at UCLA, maybe talk us briefly through how you ended up designing your lab, what your lab was like going for, how you went about recruiting PhD students, and then how that led into Determined.
Yeah, so I mean, my time at UCLA was, I feel very fortunate to
Yeah.
have been there. It was and UCLA is a great school.
Yeah.
But it was kind of a bizarre experience because for whatever reason, and UCLA is doing amazing now. Their machine learning department,
Yeah.
the people there, incredibly strong. When I was there, for whatever reason, they did not have a very big machine learning presence.
Mm-hmm.
I think when I joined, I might have been the only person who self-identified squarely. There they had a few strong computer vision people,
Yeah.
a few other people who were kind of adjacent to ML, but I was probably the only person who was a one or maybe a small handful of people who were core ML. But I was
Yeah.
a very junior professor. I had no idea what I was doing.
Yeah.
Uh, so that was an interesting experience trying to figure out things sort of on my own.
Mm-hmm.
Soon afterwards, a professor from USC joined UCLA, a more senior professor than I, Faye Shaw.
Mm-hmm.
So that was nice, somebody else to talk to. But it was a bit of an odd experience, even with Faye. Just that it was, I think it's often the case that in most places when you get hired as a professor, you're joining an area where there's other people. You can be mentored by other faculty in your area, kind of to show you the ropes. For me
Mm-hmm.
at UCLA, and I knew this going in. It wasn't, I knew what I was getting myself into. I kind of had to just make things up on my own because there was no one really to talk to for the first little while I was there.
Mm-hmm.
But yeah, I mean, that said, to answer the question of what I did, it's largely just hustling, right? Like
Yeah.
you talk to a lot of people, you're constantly trying to sell people on what you're kind of, be scrappy, be hustle, try to sell people on your vision. At least for me, one other thing was my I guess yeah, fiance at the time,
Yeah.
now wife, was still at Berkeley. So I was flying back and forth between the Bay Area and UCLA for a while.
Mm-hmm.
And so as a result of that, I also did keep a lot of collaborations with folks at Berkeley,
Mm-hmm.
just because I've been there for so long and physically was there a fair bit. And that was also, I probably would not have done that if I didn't have a reason to go back to Berkeley so much. But given that I was there anyway, that's sort of what I did.
Mm-hmm. Gotcha. And so getting into like your decision to found Determined, I guess like what was the problem that you wanted to solve with Determined? Why do you think it was the right time to solve it? How'd you go about growing that team?
Yeah, so I mean, I guess it's kind of related to my last point of
Yeah.
going back and forth between UCLA and Berkeley a bunch. Obviously, the main reason was to see my fiance.
Yeah.
But I had a bunch of friends and collaborators there. One of whom was this guy Evan Sparks, who he started grad school at Berkeley when I was towards the end of my postdoc. We collaborated a bunch together, and he kind of always had aspirations of starting a company. And we were also just good friends. So we'd always chat and hang out whenever I'd come back. And he was more of his background was in databases and distributed systems, mine in ML. So we had nice complementary interests. And so I think the desire to, I mean, for me, I find this, whether it's in academics or in industry, to me, it always comes back to people, finding really good people, not just technically, but decent people that you actually want to work with, that you trust, that you think are going to do the right thing, have high EQ in addition to high IQ. That to me is always what I'm attracted to in terms of, I'm often more attracted to who I work with than what I work on. So yeah, I think honestly, a big part of it was that Evan was someone who I loved working with. We worked really well together. We worked well. Yeah, we worked great together. We had complementary interests. And he was actively thinking about starting a company. It was always something that I felt, if it was the right time and with the right people, I'd be interested. It's a new experience. I'd like to see what it's like. And so, we ended up kind of starting a company to some extent, spinning out, research that we had been working on related to parallel distributed computing, hyperparameter tuning, AutoML, basically at the center of kind of like infrastructure for machine learning, with the idea being that like at that time, right, there were these big labs at Google and a few other companies. They had a lot of infrastructure, a lot of compute, but they had a lot of really smart systems and algorithms to allow you to, harness and automate the resources that you had available to you and actually train these models at scale fairly efficiently. And so a lot of the research we had been doing was, to a large extent, motivated by this exact idea. How can you kind of, if you have a lot of data, you have some problems you want to be working on with ML, but you're not DeepMind back in 2017, 2018, how can you get 90% of the way there, with automated, with software that allows you to automate a lot of the things that are potentially hard for you. So that we had done a lot of work on hyperparameter tuning, neural architecture search, distributed training of neural networks, things like that. And those all became kind of core components of the software that we built and sold.
Yeah, and I think what's interesting about this is you also started being an assistant professor at CMU back in 2017, if I'm not wrong, and you were doing that while you were also chief scientist at Determined AI. Maybe walk us through a
Yeah,
little
so
bit of that. Mm.
yeah, so I left UCLA in maybe the spring, roughly speaking, I'd be off by a few months, but the spring of
Sure.
2017.
Yeah.
Uh, Started the company right around then.
Mm-hmm.
Uh, Moved. My wife then was doing a postdoc at in Stanford,
Mm-hmm.
so we Palo Alto.
Mm-hmm.
Uh, so I spent, I think, like 9 months working full time at the company,
Okay.
uh, and then started at CMU. I mean, I started taking students
Mm-hmm.
in the fall of 2017.
Yeah.
So I was, and I flew back and forth to CMU a few times, but I
Mm-hmm.
think I officially started in 2018. I
Okay.
can't remember.
Gotcha.
But yeah, basically sort of had two jobs for a little while, which I think, yeah, I mean, I guess the truth about being an assistant professor, this is not unique to me. I think
Yeah.
all of my assistant professor colleagues at CMU who are amazing, amazing, amazing people
Yeah.
are all working really hard. They're doing incredible things, but,
Yeah.
it doesn't happen by magic. It happens by, working really, really hard. And
Yeah.
so I guess I was no exception there.
Mm-hmm. Cool. Maybe tell us a little bit about those 9 months while you were in Palo Alto, and also recruiting students.
Yeah, I mean the recruiting. So CMU, I spent very little time recruiting students. Then CMU has this.
Yeah.
One nice thing about CMU is that you know we attract some of the best students
Yeah.
just by virtue of being CMU.
Yeah.
But there's also this nice thing of students at CMU come with, for the most part, they come without having advisors,
Yeah.
and so there's a match process once they join. So
Okay. Okay.
I was able to recruit students by flying out and being there for a couple weeks during this match process,
Gotcha.
but I didn't have to actually do any of the recruiting before the students were already on campus. So that
Mm-hmm.
that was a pretty that was not the focus of my time in those 9 months. But yeah, starting a company was interesting. We pitched to
Mm-hmm.
the various VCs,
Mm-hmm.
we got seed funding.
Mm-hmm.
We thought, again, I had never done any of this before. I had no idea what I was doing.
Mm-hmm.
And the world was different back then too, right? We
Yeah.
thought getting seed funding was like we had won, but then we realized, you give a seed funding now, there's expectations to
Yeah.
actually build a company and do real work. And I remember, I remember being, maybe 75% excited, 25% sort of terrified after somebody actually agreed to give us money. Because like,
Mm-hmm.
oh man, now we actually, now people are betting on us and we have to do something.
Mm-hmm.
And, we basically had PowerPoint slides and that's it. Now we actually have to make this real.
Mm-hmm.
But yeah, then we I should note we had a third co-founder, Neil Conway, who
Mm-hmm.
worked with us as well. The three of us it was some mix of building a prototype, spending a lot of time on recruiting, and talking to potential customers. And yeah, you kind of do all of those things.
Mm-hmm.
And so sort of trial by fire, but you kind of figure it out. I think I spent a lot of my time on recruiting. It was something that it was kind of natural to me,
Yeah.
as well as sort of the big picture vision for the product that we wanted to build.
Mm-hmm.
I think the three of us, I was far and away the worst software engineer, so
Mm-hmm.
I spent a little bit less time on that. But
Gotcha.
yeah, you do a lot of things as a founder. You don't.
Yes.
It's pretty squishy what the role is. You're kind of. I remember at one point booking a flight for we were thinking about having a summer intern in the summer of 2018, and so I booked his flight and his hotel, right? Like we could have been more efficient and had maybe a little bit more admin help, but you just do
Yeah.
everything, right?
Yeah.
That's
Yeah.
how you
Of
get
course.
things to work.
Yeah, maybe tell us a little bit about your time at CMU. I mean, obviously you've been here for a while, probably over 7 years at this point. So maybe talk us a little bit through your time there, maybe like a few brief highlights that you think are important. And then also critically, you teach ML with large data sets, which is, a class that doesn't exist at a lot of other schools because CMU just has so many classes. Maybe talk us through a little bit of that.
Yeah. I mean, I don't know. CMU has been great. I think I would say most people would the highlights of CMU. I think again, it's the people, right?
Yeah.
The people in the environment. I think the students. I would start with the students. I love my students. I love working with them. I hope they feel the same way. But that's the thing that is far and away the most exciting thing to me. Right, working with really, really strong, especially the PhD students. You get to know them for 5-6 years. You're their boss, but it's not a normal boss relationship. You're kind of their
Mm-hmm.
mentor. You're kind of seeing them grow.
Mm-hmm.
They teach you a ton, right? They come in
Mm-hmm.
with fresh eyes. They very quickly know a lot more than you do about whatever they're working on.
Mm-hmm.
So that's the most fun part of it, I think.
Mm-hmm.
Colleagues are great too, right? I think the culture at CMU is great. It's like they have this reasonable person policy. People are just generally reasonable, right? You don't always
Yeah.
agree with each other, but it's very cordial, very polite, pleasant. Decisions are made in reasonable ways for the most part.
Mm-hmm.
So, and then just the quality of people, right? Where CMU is huge, a world leading expert on anything and anything related to AI
Yeah.
is likely in the same building that you're in,
Yeah.
um, and is happy to talk to you. And so that's just, that, at this point, I hope I don't take it for granted now, but I know when I came to CMU, it just kind of blew my mind
Mm-hmm.
that just the concentration of amazing people in
Mm-hmm.
one building or one place was pretty exciting.
Mm-hmm.
Yeah, and as for machine learning with large data sets, it was fun to teach. I will say more broadly though, teaching is confusing now, right? Our world changed with
Yeah.
ChatGPT a couple of years ago. Obviously, LMs existed before then, but
Yeah.
that class was really fun to teach. Though I will say towards the end, it felt a little bit long in the tooth, just because, right?
Yeah.
What to teach now versus even a few years ago, it's very, very different given the climate in AI today.
Mm-hmm.
But yeah.
Gotcha. I think one thing that's also interesting is you were involved with Amplify as a venture partner. For people who don't know about Amplify, they're pretty great venture firm. They help invest in a lot of really great companies. And maybe talk us through a little bit of what it meant to be a venture partner during your time there, so roughly 2 to 3 years.
Yeah. So Amplify led our seed round for my startup. When we
Got
got
it.
acquired in 2021,
Mm-hmm.
you know, I stayed at our acquirer
Mm-hmm.
HPE for full time for
Mm-hmm.
like, I don't know, 6 months.
Mm-hmm.
But after that, I was trying to figure out what to do next.
Mm-hmm.
Wasn't quite ready to do something maybe full time or close to full time in industry.
Mm-hmm.
Uh, but Mike Dauber, who was one of the GPs at Amplify and the
Mm-hmm.
person kind of most that we most interacted with at Amplify as part of our startup,
Mm-hmm.
he reached out and asked if I wanted to work kind of in a part-time capacity
Mm-hmm.
with Amplify, which was awesome. I was actually about to reach out to him around the same time to see if he'd be interested in that. Yeah, and it was great, right? At least for me, the what I took out of it selfishly was I just wanted to see how the sausage was made,
Mm-hmm.
how VC firms kind of figure out what investments to make, how they help their companies, how the whole process works, just seeing what it's like on the other side, right?
Mm-hmm.
Like our startup, I had a sample size of one. We did a bunch of things wrong. The outcome ended up being, fairly good for us, but I did not really feel like I knew exactly what was going on
Yeah.
or had mastered the skill set of starting a company, having done it once. I also wanted to just stay connected with the startup community,
Yeah.
especially the AI startup community.
Yep.
And working with a company or working with a firm like Amplify was a really natural way to do that.
Mm-hmm.
So it was great for me. I learned a lot from their point of view. I hope they benefited from it. I think, a lot of venture, especially early stage venture in a company like Amplify,
Mm-hmm.
who they're absolutely amazing. They really focus on super early stage. I think
Mm-hmm.
Dauber in particular and I share this philosophy. It's all about people,
Mm-hmm.
right? He's an absolute wizard in terms of finding good people, staying in touch with them, helping them, connecting them with other good people.
Mm-hmm.
But if it's all about people, networks are important,
Yeah.
and they're very well connected. But I, understandably, given my background, I had a slightly different set of people that I knew,
Mm-hmm.
and so helping connect different groups of people together was something that I was helpful with.
Mm-hmm.
Also, talking to them about different AI trends, at least the way I saw them,
Mm-hmm.
I think was somewhat helpful to them.
Mm-hmm.
But yeah, no, it was really a lot of fun. It was, it was definitely a part-time sort of thing.
Yeah.
But I learned a ton.
Mm-hmm.
I learned how venture works, how the cadence of it, how things, just how important it is to network, how you just
Yeah.
help people as much as you can. You don't really know where things are going to lead, but eventually good things happen. Yeah, and I was working there through I think the end of last year,
Mm-hmm.
when I decided to start taking on something more serious at Datadog, and which was a natural time for me to kind of stop.
Mm-hmm. What motivated the choice to become a chief scientist at Datadog?
Yeah, I mean, I think I was ready to go back do something more serious in industry. To be
Yeah.
honest, if you had told me a year ago, I would have more likely thought that I would have been starting another company, right?
Yeah.
Given my background, my interests.
Yeah.
But I will say, in parallel to thinking about starting companies, I was also talking to, several bigger companies to understand kind of what AI problems that they were facing. To me, kind of what I realized a couple of years ago was, after ChatGPT took off and everything kind of changed, was as cool as I think these frontier models are, and the people working there are amazing. The progress that these models that we're seeing, these models, is truly fantastic. But I was more interested in what I call vertical AI, working on cutting edge AI, but in the service of actually solving real problems. Not to say that frontier models aren't solving real problems, but right, they are more abstract and general purpose. I wanted
Yeah.
to target specific verticals, specific real problems. And that's what I still remain mostly curious about in terms of, for AI truly to transform our society, it's going to have to solve real problems, not a suite of benchmarks that we researchers come up with. So that's what I was looking to kind of think about. It became clear to me that I don't really know anything about any verticals. And I have no data. And so starting a company, given that that's what I was interested in, just probably wouldn't have made sense for me. So I started to talk to a bunch of different companies, and then Datadog among them just stood out as being just far and away the best opportunity. Both, I think, just given the way they're positioned, then also kind of personally for me. I mentioned a long time ago in our discussion how when I finished my PhD, I had three options. One was postdoc, one was Google Research, one was a startup. Turns out that startup was Datadog. So like the two founders of Datadog are close friends of mine. I, for a hot second, thought about starting it with them. I made potentially the wrong choice of not doing that, partly because they were focused on observability and not AI and observability.
Yeah.
They made the right decision at the time. But I was talking to Alexi, one of the two co-founders, maybe a year and a half ago. He was pinging me just to talk about how Datadog could get more engaged with research and with academics, and that one conversation led us to talk more and more. And to be honest, I'm still not a world-leading expert on the domain of observability. But the more I learned about it, the more I realized that, they're solving really real problems. They're in a business that's fundamentally focused on collecting data and analyzing and reasoning about that data. And so it's a vertical where it seems super ripe for AI to potentially have high impact. It is fundamentally an engineering company, so they move incredibly fast in every other facet of what they do. And so while they weren't yet a powerhouse in AI research, they were incredibly well set up to kind of become one very quickly. And then, beyond that, people, right? Alexi and Olivier, they're really good, but they're really decent people. The culture at the company is absolutely amazing. And being able to talk to them very directly about what their intentions were, what their goals were, we were just really well aligned. So it eventually made the decision pretty easy. And yeah, it's been 6 months and it's been really a lot of fun.
Gotcha. Maybe let's get into a little bit of some of the research that you've done in your lab. From what I understand, like it's pretty broad. Like there's been a lot of different papers sort of across the board. Do you want to talk maybe briefly about some of your research with Copilot Arena, and then also federated optimization? It feels almost like, earlier on, like throughout your time doing your postdoc at Berkeley, you sort of had this, strong emphasis on like federated learning and some of the more systems aspects. I think you were also maybe involved with MLSys, like that conference.
Maybe I'll go chronologically very quickly. When in grad school, I was interested in distributed learning, but maybe more theoretically. Did all my coding in MATLAB, was proving bounds on various methods that I was coming up with. Came to Berkeley, was still interested in, at that time, big data was becoming a thing. So again, parallel distributed computing. But now I was sitting in a lab surrounded by preeminent, distributed systems and database researchers. Right, the Spark was being built by Matei, sitting right next to me.
Yeah.
So I started thinking about distributed machine learning, large-scale machine learning, but in a much more systemsy, practical, and I think more kind of, more practical, and I think, at least for me, interesting point of view, trying to get these things to actually work. And so that led me for a while to kind of work on machine learning systems, MLSys, before it was a thing. I think I would argue at that time, maybe the only places that were doing machine learning system was our lab at Berkeley and some folks at CMU as well. So did a lot of machine learning system stuff, parallel distributed computing. That led to a bunch of work on kind of, like I was saying, hyperparameter tuning, AutoML. We came up with a bunch of, I think at that time, pretty well-known hyperparameter tuning optimization methods that led to work on, neural architecture search as well. somewhere along the way that we started this machine learning systems conference. That's been pretty nice to see.
Yeah.
When I was a postdoc, folks like me were kind of in between two communities, and it's nice to work in between communities, but as an academic, having a home is useful. Having people who self-identify as being like you
Yeah.
is really useful for your career. And I think, fast forward 10 years, MLSys, people are interviewing at CMU every year now, very proudly identifying as MLSys researchers, which is kind of, it's a cool thing to see how things have changed there. I will say when I started my company, though, in 2017, partly because I really didn't want my students working on the same things as my company for kind of conflict of interest reasons, I kind of moved away from, at least research-wise, a little bit MLSys stuff. But I guess I kind of moved away from that, moving back more towards kind of core ML. But even then, a big thing we started working on was federated learning, which I would argue actually, I guess, is within the MLSys arena. But we were thinking about it more from an ML point of view. And I think the work with federated learning, this was large. A lot of this work was with my wife, Virginia Smith. But a lot of that, I think, happened from being at the right place at the right time. Right, we were some of the first people thinking about parallel and distributed machine learning. At its simplest level, when people first started thinking about federated learning, the way we started thinking about it, we're like, all right, phones are getting more powerful. Instead of doing distributed machine learning in a data center, can we do it on phones? And we happened to write some of the first papers on some of the very basic ideas there related to distributed optimization, which was this Fed Prox paper. We wrote a paper on, multitask learning, which was this COCO paper. We created the first benchmark. We wrote a survey paper, and the fact it helps being first in an area that gets really big. And so we wrote a bunch of papers, I think, on fairly basic ideas. But they were kind of some of the, I think, people realized there were some of the natural ideas that you might think about, and so they, ended up being pretty well received. And then I guess more recently, I guess I've worked on, one area I've been really interested is, machine learning for diverse tasks or specialized machine learning, or what I'm now calling vertical AI. So I have a long line of work on that related to neural architecture search, or how to repurpose language models for downstream tasks that are not language-based. But another big area has been on kind of human AI interaction. And one offshoot of that, and a lot of this work is with a star student of mine, Valerie, and she and Wayne, another one of my students, amazing rising third-year student, they led this project Copilot Arena, which is really focused on kind of human AI interaction, but focused on evaluation. The idea being that if you want to evaluate the quality of AI systems that are meant to be kind of assistants or meant to be interactive, you want the evaluation itself to be interactive. The best example of this, obviously, the most prominent example of this is Chatbot Arena for chatbots. I guess it's now called LM Arena. They spun out a company around it. But we took those similar ideas and actually worked directly with them on taking those same ideas but applying them to coding assistants. So things like I guess Cursor or Copilot. Wayne and Valerie built the infrastructure to allow you to kind of basically an open, free way of getting coding assistants to work in your VS Code environment. But instead of just being given kind of a suggestion, you're given two suggestions. You have to pick which one you like better. And we kind of take the votes that people move with their feet, they pick what they want, and you can take that user feedback and kind of use that to rank the quality of different models. It's been really, it's proven to be pretty well adopted, and I think it's kind of the right way to be doing evaluation. Evaluation generally is one of the biggest problems in AI today, just full stop. I think doing things interactively is probably the right way to be doing it. Gamifying it in some way is helpful to actually get that feedback in a way where people are incentivized to actually to do evaluation and give you feedback.
Do you want to walk us through very quickly in like maybe a minute or so some of the stuff that you've done with AI for science? I think it's definitely a field that a lot of people are bullish on, including me and Zico. Want to sort of run us through that?
Yeah, I will say that what we've worked on so far, I think, is just scratching the surface. I think that like the main things that I've looked at so far, which I think are interesting, but the methods first, are ideas of there's been a lot of work, obviously, on building frontier models, bigger and bigger language models that can, do more and more impressive things. There's also been kind of, as a result or inspired by that work, a lot of more recent work building kind of specialized foundation models, say for genomics or for some other sort of whatever specialized time series or any other domain you might care about. And there's a question of what is the right, most efficient way to kind of build these specialized models. And in some sense, can you kind of can you kind of, instead of starting from scratch, can you stand on the shoulder of giants and potentially repurpose or reuse whatever artifacts already exist from language models in the service of maybe these other domains? So we had this paper, which I was super excited about a couple of years ago now, led by my student, Junhong, where the idea was basically the question, can we repurpose a language model, say, for a downstream task in genomics or a downstream task in, say, PDE solving? And the long and short of it is that if you're a little bit careful about how you do this repurpose, like naively fine-tuning doesn't really help you.
Yeah.
You're clever about how you do things. There's a way to do some version of kind of continued pre-training. Or in other words, another way to think about it is you can kind of initialize this new foundational model that you want to create for some specific domain. You can initialize it with a pre-trained language model, and that turns out in many cases to really give you a big boost if you do things the right way, which is a really nice idea, given it works, in that it allows you to reuse things. You can imagine as language models get better, you can just continually initialize with better and better starting points for your specialized models. And we've subsequently taken that idea and worked with computational biologists and are working with folks who are experts in kind of solving PDEs to try to kind of push that idea further and further. And I'd argue that, like, in both of these directions, we've gotten to the point where we kind of have state-of-the-art foundation models for these different domains. But I would still say that, I think to have true impact in any vertical, you have to go pretty deep in that vertical.
Yeah.
And where we are right now in both of these two verticals is still, the community agreed upon benchmarks as opposed to kind of translational impact within any of these particular scientific domains. So it's exciting and it's promising, but there's still work to do there, I'd say.
Totally makes sense. All right. Well, thank you so much for coming on, and thanks for walking us through your very awesome background over so many years. Thanks for coming on the podcast.
Yeah, thank you. I appreciate it.